Hi everyone, in this example we're going to be looking at a neutralization reaction and calculating the concentration of one of the solutions within the reaction. So if we take a look at this example, which is example 5 in your notes, it says 25 milliliters of 0.325 molar hydrochloric acid completely neutralizes 35 milliliters of a calcium hydroxide solution. What is the molarity of the basic solution? So with this neutralization reaction, there are some steps that we need to take. The first step is to write and balance the equation. So we need to have an equation to work with. The second step is going to be to determine the moles of calcium hydroxide that we use. And the reason that we want to determine the moles of calcium hydroxide used is so that we can calculate the concentration of the calcium hydroxide. So the first step was to write and balance our equation. So if we take a look, we have HCl, which is aqueous. Think about why hydrochloric acid is aqueous, plus calcium hydroxide, which is also aqueous, yields calcium chloride, aqueous, plus water, which is a liquid. Now again, think about why is HCl and CaOH aqueous? Well, strong acids and strong bases are strong electrolytes, meaning that they dissociate in water, and so both of those are aqueous. The calcium chloride is aqueous because it is an ionic salt, so that makes it soluble in water, and just remember your solubility rules as well. So from this, when you balance it, you need a 2 in front of the HCl, you need a 2 in front of the H2O. That makes it balanced. Now this is the overall molecular equation. This gives the overall stoichiometry. Think about this now. What would be the net ionic equation for this overall neutralization? So I want you to pause the video and I want you to write out what the net ionic equation of this neutralization reaction would be. The second step is to find the moles of calcium hydroxide from the hydrochloric acid that was used. So we know that we need to find moles of calcium hydroxide. Now in this case we're going to use stoichiometry. They give us volume of hydrochloric acid and they give us concentration. I wrote both of those values underneath the balanced equation just to help us out. I also wrote any information about the calcium hydroxide that might be useful. So what we're going to do is we're just going to use stoichiometry using this HCl. We have 25 milliliters of 0.325 molar. So what I did down here, start with my volume. Remember, if you're given mass or volume and the molarity, always use that mass or that volume as you're given because molarity is a conversion factor. So we have 25 milliliters of HCl. I converted it to liters. Then I use the molarity to go from liters to moles of HCl. So at this point right here, if we don't look at anything else, we just found moles of HCl that we used. Moles of HCl to completely neutralize that base, that calcium hydroxide. Well, if we solve for moles, we get 0.008125 moles of HCl. Now, if we look at this balanced equation, notice it's not a 1-to-1 ratio. Complete neutralization means that your acids and your bases need to equal, but you also have to take into account the mole ratio. So because it's not a 1-to-1 mole ratio, we have to take that into account, and that's what I did over here. So I had moles of HCl. I actually used twice as much HCl as calcium hydroxide per my mole ratio. So if you look at this, for every 2 moles of HCl, I need 1 mole of calcium hydroxide. When I solve this, I get my moles of calcium hydroxide. Now think back to what the problem said. Look at your notes. The problem asks for molarity. Well, now I have moles of calcium hydroxide and I have volume of calcium hydroxide. So I can take those two values and use the molarity equation, right? Molarity is moles of solute over liters of solution. So I have my moles of solute, which is my calcium hydroxide. I have my volume in liters of solution. Remember, it was 35 milliliters, so it's 0.035 liters. If I divide the two, we get 0.116 molar CaOH2. Remember, the capital M is molar. It also represents moles per liter. I used 3 significant figures because my given information had 3 significant figures. Now, as you work through this, instead of just using the stoichiometry in the second step, you could have used a BCA table, and you could have just looked at the ratios to figure out how many moles were used and gone from there. That should have given you the same answer. If you try that way and you have questions, feel free to send me an email and to ask, but you still should always get 0.116 molar calcium hydroxide.